All right, this video is more practice examples for rationalizing the denominator. The first question says, rationalize the denominator of 1 over the square root of 7. The idea of rationalizing is to get the radical out of the denominator of a fraction. We do that by multiplying it times itself, because when you multiply the square root of 7 times the square root of 7, you get the square root of 49, which is 7. But the rule with fractions, whatever you do to the denominator, you also have to do to the numerator to keep the equality. So the numerator turns into 1 times the square root of 7, which is the square root of 7. Don't make the mistake of trying to reduce these. The square root of 7 and 7 cannot reduce because they're not the same number. So this is your final answer. The second one says rationalize 2 over the square root of 12. So we're going to get rid of the square root of 12 by multiplying it times itself. There's actually a couple different ways you could do this. You could have simplified the square root of 12 first, and maybe we'll go back and try it that way. The square root of 12 times the square root of 12 is 12, the square root of 144. Whatever you do to the denominator, you also have to do to the numerator. So now we have 2 times the square root of 12 in the numerator for multiplying these. This one's on the outside, this is on the inside. Now, the 2 and the 12 here will reduce. They're both coefficients. We know that 2 over 12 makes 1 over 6. So this turns into the square root of 12 over 6. But this square root of 12 can also simplify. So maybe we should have done that first before we reduced, but it's okay. It doesn't really matter what order you do these in. This is 4 times 3. The square root of 4 is 2. So 2 square root of 3 over 6, and again, this 2 over 6 reduces to be 1/3. So 1 times the square root of 3 over 3. All right, the square root of 12 over the square root of 3. If you remember from the fraction rules, we can put these back together. 12 is divisible by 3, so it might be beneficial for us to do this. Put these back together. 12 divided by 3 is 4. We get the square root of 4, which is 2. If you didn't see that, and you went about it by multiplying times the square root of 3 to rationalize the denominator, it's okay. The square root of 3 times the square root of 3 is 3. The square root of 12 times the square root of 3, they're both on the inside, so they multiply to make 36. This is the square root of 36 is 6 over 3, which makes 2. This was less work, but this got you there. Just a few more steps. Rationalize the denominator. We're going to multiply the square root of 6z times itself, and that's going to give us 6z. We have to do the same thing in the numerator. So we end up with 16 times the square root of 6z. But the 16 over the 6 will reduce. They're both divisible by 2. So we have 8 times the square root of 6z over 3z. Okay, 3x squared over the square root of 2x. We're going to multiply the denominator times the square root of 2x, and that's going to give us 2x in the denominator. We multiply the numerator times the same thing. We get 3x squared, square root of 2x. And when we look at these, we can see that these x's should reduce here. The 3 and the 2 won't. So we'll leave the 3 and the 2 there. These x's, x squared divided by x leaves me with 1x in the numerator. And I still have my square root of 2x. So this is the final answer. Six over the square root of 7xy. We're going to multiply the denominator, the square root of 7xyz times itself. That would give us 7xyz. When you multiply a square root times itself, the square roots multiply out. So the square root of xyz here, and that gives us 6 square root of 7xyz. When I look here, the 6 and the 7 will not reduce, and this xyz don't have any variables outside here to reduce with, so this is our final answer.